Hello students. So today we'll see Unit 2. So we'll move on to IoT components. So here in this chapter, we'll see introduction to sensors. So when we are learning sensors, we'll see the description and the working principles. So different types of sensors we'll learn in this particular unit. So working principle of basic sensors, and we'll be seeing the types of sensors like ultrasonic sensors, IR sensors, MQ2 sensors, temperature and humidity sensors, digital switch and electromechanical switches. So these are the topics involved in Unit 2. So first we'll move on to the introduction part. So moving on to the introduction, so we'll see what are the types of, we'll see what is a sensor and we'll move on to the types. So sensors are basically the devices that detect changes in the environment. So it will perceive from the environment and it convert these changes into signals. So that can be measured and it can be recorded. So when you consider sensors, it can be used anywhere in the environment. For example, like it can be used in the machines, cars, buildings, and any other network devices that allow interaction and cooperation of these objects to reach common goals. Okay, so they are the integral part to many systems. So it enables automation and data collection in various fields. So all the information are collected and it is recorded, and it also has a repository. So for example, like it involves various fields like healthcare. So there are so many healthcare sensors. Automotive industry, we use so many sensors. Consumer electronics, we use so many sensors. So when you consider sensor, it is derived from a Latin word sentire. So meaning it is to perceive. So this is the basic introduction about sensors. So it's nothing but, once again I'll tell you, sensors are devices that detect changes in the environment, and that particular information is converted into signals that can be measured and it can be recorded. Okay, so moving on to the next slide. So we'll see the components of a sensor system. So we have four components here. So sensing element, transducer, signal conditioning, and output interface. So considering sensing element, so it is the part that interacts with the physical stimulus, right? So initially it gets a response from the environment. So it's a physical stimulus. So it's a part that interacts with the physical stimulus. For example, we can say thermistor for temperature, right? And for considering transducer, it converts the sense data into an electrical signal. And moving on to signal conditioning, it performs amplifies, it uses filters, or it digitizes the signal. And it can also consist of output interface. So it can be either analog, digital, or wireless. So it communicates the data to a controller or a network. So these are the four important components of a sensor system. So moving on to the classification, we'll see what is the basic ideology of IIoT. So it is the cutting edge IoT technology where big data analytics are used along with artificial intelligence. So to improve the industrial production processes, we use industrial IoT that transform traditional manufacturing practices. So it also plays a vital role in enhancing the production and its efficiency. So there are so many types of sensors. So we have active and passive sensors. So considering all these sensors, it plays a vital role in production efficiency, and it also reduces resources. Along with that, it also reduces the power consumption and improves its products quality. Okay, so these are the basic ideology of sensors used in IIoT. So there are several classification of sensors. So we'll see one by one. So in the classification of sensors, it is divided into two types of sensors. One is active and passive sensors. So first you have to understand what is meant by active sensors. So active sensors are those which require an external excitation signal. or a power signal. Okay, so it requires an external signal, or it can be considered as a power signal. So that process we call it as an active sensors. And the second type, we call it as passive sensors. So passive sensors, on the other hand, do not require any external power signal, and it can directly generate output response. So these are the two types. So you have learned about active and passive sensors. So the other type of classification is based on the means of detection used in the sensor. So some means of detection are electric, biological, chemical, radioactive, etc. So the next classification is based on conversion phenomenon. That is, the input and the output can be considered. So some of the common conversion phenomena are photoelectric. So we can also consider thermoelectric, electrochemical, electromagnetic, photoelectric, etc. So these are the conversion phenomenon we can consider for these particular sensors. So next we'll move on to the types of sensors. So here we have the diagrams for the different types of sensors. So we have different types. So first we'll see what is meant by proximity sensor. The other type of sensors we have temperature sensor, ultrasonic sensor, vibration sensor, tilt sensor, level sensors, touch sensors, soil moisture sensor, gyroscopic module sensor, everything we have. So in the next slides we will see some types of sensors in detail. So these are the basic types of sensors which we use in real-time environment. Moving on to the temperature sensor. So if you know, so what's the use of temperature sensor? So it is often used in homes and offices to measure the temperature. And moving on to the proximity sensor, we use to detect objects in automatic doors, etc. So for that purpose, we'll be using proximity sensors. And next we have accelerometer sensor. So mainly for screen orientation in smartphones, etc. So IR sensor, we call it as infrared sensors. So for remote control TVs and for other remote control devices, we'll be using IR sensors. And moving on to the next sensor, we have pressure sensor. So it monitors the tire pressure in vehicles and so on. So that's the purpose of pressure sensor. And we have other types also, for example, like light sensor. So to adjust the screen brightness on smartphones, or in home automation, we can use light sensors. And next we'll move on to electronic sensors. So ultrasonic sensors, sorry. So it is used in parking assistance for cars. The next type of sensor is flow and level sensors. So here we have to monitor the water levels in tanks. We can use this type of sensors. And the next type of sensors is smoke, gas, and alcohol sensors. So it can also detect smoke and what type of smoke it can also detect. So gas sensor is very similar to smoke sensor. And next we have alcohol sensor. So it can detect based on the environment. So microphone is nothing but the sound sensor. So it can be used for voice recognition and smart speakers. So these are the different types. So we other than this we have touch sensors, color sensors, humidity sensors, magnetic sensors. So magnetic sensors are otherwise called as Hall effect sensors. So it is used to detect the position of a rotating object. So position sensor is used to track the position of machine parts, and color sensors will be using. So to monitor the humidity sensors, we'll be using humidity sensors. It can control humidity levels in greenhouses. And moving on to the next types of sensors, we have tilt sensor. So it detects the tilt of gaming controllers, etc. So it can be used in that application. So we have PIR sensor where it can detect motion in security systems. So we have gyroscope sensors, optical sensors, strain and weight sensors. So these are all the different types of sensors. Other than this, we have capacitive sensor. So it's used in touchpads on laptops. So piezoelectric sensors, it's used in detecting vibrations in musical instruments. So thermal sensor, we can use it in ovens for temperature control. RFID sensor is used in tracking inventory in our warehouses, and in different applications we can use RFID sensors. Chemical sensors, right? So the presence of chemical can be found out. So it can also be used for monitoring the air quality, and this represents the working of basic sensors. So, if you see the working of sensors, so an input is received from the sensor. So, it has a processor and it also has an actuator. So, the actuator will give you the output. So, here we have two main parts where you have transducers input and transducers output. Okay. So this has actually is the main part here. So the input is collected from the sensor. So it processes the information. It can store the information, and according to the input, some triggering action can be done. So based on the triggering action, some output can be generated. So this is the basic working of a transducer, and it converts the signal from one physical form to another physical form, right? That's the main application of a transducer here. So it is also called as an energy converter. For example, we can say microphone converts sound into electrical signal. So it is based on the principle of conservation of energy, right? So we have some common and most popular sensors. So we'll see one by one. So a temperature sensor, as the name suggests, we can sense the temperature from the environment. So it can measure the changes in the temperature. So there are different types of temperature sensors. We'll see one by one. So for example, like LM35 is, we call it as temperature sensor. Other than LM35, we have DS18B220, thermocouples, RTD is used, resistive temperature devices. So these are the temperature sensors. We can use it here. And temperature sensors can be analog and it can be digital. So in an analog temperature sensor, the changes in the temperature correspond to changes in temperature can correspond to various sensing objects. So we can see some applications here. So we can also use temperature sensors in the home automation system, or in offices, or in buildings to monitor the temperatures. So moving on to the next part, we have a proximity sensor. So you have to know what is meant by a proximity sensor. So a proximity sensor is a non-contact type sensor, so that detects the presence of a object. So proximity sensors can be implemented using different techniques like optical, like we can use infrared or laser. So sound, we can consider ultrasonic. So magnetics effect, we can use it as Hall effect sensor, capacitive, etc. So we have some applications here. So it can be used in parking, it can be used in industries. So to monitor the ground proximity in aircrafts, it can be used. Proximity sensors can be used. Capacitive proximity switches are commonly used in applications such as level sensing. So it can monitor liquid detection, and moving on to the object proximity detection, it can detect harsh application in environments, and they are widely used in automatic pump control systems. So we'll see some examples here. So examples of capacitive proximity sensors. The most popular capacitive sensors in the market are CR18, 8DN, and we have another type CR30, 15AO. we have the other type called as M12, M18 and M30, etc. So these are the types of most popular type of proximity sensors. So this is the diagrammatic diagram for inductive proximity sensor. So these type of proximity sensors can be used in mobile phones. It can be used in cars for parking. It can be used in industries for object alignment. And moving on to the ground proximity sensor, it can be used in aircrafts, etc. So proximity sensor in reverse parking can be used here. So for example, there can be various projects, and we can use the implementation of inductive proximity sensor. When you consider these type of sensors, so this is a type of oscillator which generates an electromagnetic field. So the target object, it can be a metal. So when it enters the field, it induces eddy currents. So these eddy currents alter the fields, trigger a change in the output. So the sensor sends a signal to the controller. So there is no contact required for this type of sensors. So applications in smart systems, for examples like IoT in edge devices, we can use proximity sensors. So real-time object detection with minimum latency can be done. So it can also be used in healthcare and Internet of Medical Things. So non-contact patient monitoring or equipment tracking can be done along with the proximity sensors. So it can also be used in industrial automation. So position sensing, conveyor control, collision avoidance can be done. This proximity sensor can also be used in security systems. So it can also control access. It can also access control, intrusion detection, etc. So these are the applications of proximity sensors. So, when you consider proximity sensors, it uses an electromagnetic field. So the target object is nothing but it's a metal which enters the field and induces eddy currents. So these current alter the fields and it triggers a change in the output. So this is the main function of a proximity sensor. And considering next we have ultrasonic proximity sensors. So this particular sensors are used to detect sound waves to detect objects. Okay, so it uses sound waves to detect objects. So these sensors emit high frequency sound waves, and it measures the time it takes for the waves to bounce back after hitting an object. So by analyzing the time delay, it senses the object distance. So the sensor determines the distance to the object. So applications of ultrasonic proximity sensors, we can see. So ultrasonic sensors are used in presence to detect the presence of an object. So it can also be used in level sensing. For collision avoidance system, we'll be using this type of sensors. So other than this, we can also use ultrasonic sensors in autonomous vehicles for object detection. So we'll see some examples here. So proximity sensors, ultrasonic proximity sensors include MB1242. So that's the type of ultrasonic proximity sensors. MB1001, NU40A141, and MB1634HRLV. So these are the ultrasonic proximity sensors. So moving on to photoelectric proximity sensors. So in this kind of technique, the photoelectric proximity sensors employ light to detect the presence or absence of objects. So based on the light, so it detects whether the object is present or not, right? So in this kind of technique, an emitter delivers a beam of light directly towards the receiver. So it identifies, so this laser beam identifies the presence when an object breaks it. Okay, so this kind of system necessitates the use of both an emitter and a separate detector, so which makes the installation and wiring process more difficult. So it consists of a light emitter and a receiver. So when an object interrupts the light beam, it changes a cause in the receiver's output. So photoelectric sensors are available in various types, right? So we call it as retroreflective and diffuse reflective. So they are widely used in conveyor systems, packaging, and object counting applications. So the advantage is that it has the largest sensing range, and it is the most accurate of the sensing techniques. So it is one of the useful sensor. So that is nothing but photoelectric proximity sensor. So depending on the sensing method, there are main types of photoelectric proximity sensors. So, when you consider a photoelectric proximity sensors, this is the working. So, we have a light beam, right? So, in between it has an object. So, the transmitter produces the light source and it is passed on to the object. So, based on the receiver, so signal light is interrupted. So, based on that particular information, it senses the whether the object is present, or it will sense how long the object is placed from the light source. So, for example, we can say the optical type proximity sensors are widely used in conveyor systems, packaging, automatic dispensers, and it can also be used in object counting applications. So, this is the working principle. So, you can easily find such sensors in everyday objects like automatic soap dispensers, toys, vending machines, automatic doors, etc. So, for example, we can say it can we have um, photoelectric proximity sensors. We have E18 B8 NK is a type of photoelectric proximity sensor. Other than this, we have TCRT 5000 and RPR 220. So these are the types of photoelectric proximity sensors. So the optical type proximity sensors are widely used in these applications. So moving on to this part, we have accelerometers. So accelerometers measures acceleration. So it is used in vehicles. The change in speed, direction, and intensity of movement can be measured by using the sensors. So this is how the data from these IoT sensors are used. So, accelerometers are used to collect data from connected devices such as wearables, medical alert devices, cameras, and cars to track the activity. So, tablets and smartphones also rely on accelerometers to know when to rotate displays based on the device physical orientation. So moving on to the next part, we have air quality sensors. So in air quality sensors, we measure the levels of pollution. So there are so many types of gases present in the environment. So if you want to monitor the each type of percentage of gases present in the environment, we can use air quality sensors. This type of monitoring can be done in urban and residential air monitoring environments. So we can use this type of sensors. So cities typically use devices with air quality sensors, so they can access real-time air quality conditions and they can provide warnings if needed, right? So air quality sensors are being used in homes as well. So yeah, to detect whether there is a presence of harmful gases or etc., or it can be used in indoors to find out the level of toxic gases. And in case if the toxic amount is a little bit high, we can use an exhaust fan, or we can open up a window to exhaust all these gases. So nowadays, cities increasingly rely on air quality sensors. So it always monitors the pollution levels in real time. So enabling timely alerts for residents and supports long-term environmental studies. So these sensors also make way to homes where you can detect indoor pollutants. So often from sources like gas stoves, and it can give a necessary action, or it can give a prompt to open up the windows, or you can use an exhaust fan to maintain a healthier living environment. So this is the type of air quality sensors. And next we have biomedical sensors. So biomedical sensors is nothing but it's used to measure a person's vital signs. So it can be done by a wearables, or it can also be used to check the heart rate and oxygen levels. So we have wearable devices like smartwatches, or we can say armbands, so that can be equipped with medical sensors. So smart wearables for health monitoring, it's very useful nowadays. So modern wearable devices are available nowadays, such as smart watches, and we can have fitness bands. So the amount of these sensors are increasing day by day. So biomedical sensors usually continuously track vital signs, and it gives psychological data and other information from the uh, human parts. So this information is relayed either directly to the user, so empowering them to stay informed about their health. In a remote patient carrying system, uh, by using these wearables, we can monitor the health of patients. So the medical professionals will be handling all the information. So enabling real-time monitoring of patients and loved ones from afar. So these technologies are reshaping personal and clinical care, so by bridging the gap between everyday wellness and professional oversight. So biomedical sensors measures a person's vital signs like heart rate and other information from the body. So uh, patient are cared even in an a different environment. So we have a remote monitoring healthcare system. So by using wearables or by using biomedical sensors, we can track the patient's activity and their vitals. So, so these technologies are reshaping personal and clinical care by bridging the gap between everyday wellness and professional oversight. So moving on to the camera, so it can also be considered as a sensor. So vision systems powering smart environments is possible nowadays. So cameras provide images, it capture visual data and images. So everything from various environments like smart refrigerators to autonomous vehicles, it relies on cameras. So where it is used to detect objects and monitor their surroundings, right? So cameras serve as an essential sensory tool nowadays, enabling object detection and environmental awareness. We have so many types of cameras. So cameras can be used in factories, industries. It can be used in warehouses. It can be used in roads. So it helps in automation and in so many environments. Cameras can be used. So in smart cities, they underpin infrastructure for public safety. So while in homes and businesses, they enhance security through real-time drive automation. So it can be used in factories and warehouses. These inspection and streamlining operations with visual intelligence can be performed by sensors like cameras. So next we'll move on to chemical sensors. So we'll see how chemical sensors are used in environment, and it can be used in health monitoring of patients. So chemical sensors play a vital role in safeguarding environments by detecting hazardous leaks in industrial settings. So it also prevents accidents, and it can ensure regulatory compliance. So chemical sensors detect chemical changes like radiation and pH levels in air or liquids. So to find out the chemical composition or chemical substance, we can use chemical sensors. So chemical sensors are used for in the environmental monitoring, in like detecting chemical leaks in factory and so on. So So here, beyond factories, these sensors are now being used in wearable technologies to analyze the chemical composition or bodily fluids, so such as sweat, saliva, and tears. So this enables the real-time insights into a person's health, paving the way for earlier inventions and more personalized therapeutic care. So they are also being integrated into wearable devices to monitor the chemical composition of other physical therapeutic use. So moving on to the next part is electric current sensors. So electric current sensors measures the amount of electricity running through a wire by monitoring the magnetic field, and it generates current along the wire. So it is this type of electric current sensors are used in smarter energy management. So electric sensors detect the flow of current in a wire by measuring the magnetic field produced around it. So these type of sensors are used to monitor the energy consumption. Remote insights into power usage. So this type of current sensors can be yeah. So this type of current sensors can be currently used in environments like data centers. So they help optimize energy efficiency. So it can also prevent overloads and support predictive maintenance. So this keep track of electrical performance across complex systems. So this is the main application of electric current sensors. So moving on to flow sensors, it's so this type of sensor measure how quickly liquid or gas flows in a tube or in a pipe. Okay, so a flow rate that is too fast or too slow could indicate a problem, or it can indicate a leak. So flow sensors for infrastructure and resource intelligence can be applied with flow sensors. So it is the measure of the velocity of liquids or gases as they pass through the pipes. It can offer the critical insights into the system performance. So if there is any deviation in the flow rate, whether it can be too high or it can be too low, so it can signal issues like leaks or blockages. So this can be used in urban infrastructure. So these sensors are essential for managing water distribution networks, and it can also detect anomalies. So they are also embedded in smart metering systems to track the consumption of utilities such as water and natural gas, enabling precise billing, conversation efforts, and predictive maintenance. So this can be also used in mining industry, right? So where there is a flow of liquid or gases, it can predict the sensing of liquid and gases, and we can monitor the performance in each industry. So next we'll move on to gyroscopes. So gyroscopes are the very common sensors used in IoT. So to enhance the safety and the user experience, we use gyroscopes to monitor the angular velocity. So it's nothing but it senses the angular velocity. It's nothing but it checks the speed of rotation around an axis. So, in industrial settings, gyroscopes can be used to detect and identify safety issues like careless forklift driving inside a warehouse. So, for example, how fast a device rotates around an axis can be monitored by using this gyroscope sensor. So, in industrial environments, this data is leveraged to identify unsafe behaviors. For example, the overspeeding or the malfunctioning of delivery vehicles can be found out. So, it enables proactive safety interventions. So, it can be paired with accelerometers. Gyroscopes also play a central role in consumer electronics. So this type of sensing devices can be used in powering display orientation in smartphones, tablets, and gaming consoles. So when you consider the other applications together with this sensor, they enable responsive interfaces and immersive user experiences while supporting all these real-time monitoring across diverse applications. So we can use all these type of sensors in the current environment. So it is mainly used for safety, and it is used to enhance the user experience. So next we'll move on to humidity sensors. So it's a very common sensor used nowadays in smart environmental control. So humidity sensors are nothing but it monitors the humidity or the amount of water vapor in the air. So humidity sensor measure the concentration of water vapor in the air. So it provides essential data for maintaining optimal indoor conditions. So maintaining indoor condition will be used. I will be using humidity sensors. So it is widely used in smart building systems, and it can be used in industrial environments. So these type of sensors, they help regulate comfort levels, and it can improve energy efficiency. So when you consider these type of sensors, these sensors is often integrated with the temperature and water sensors to enable comprehensive remote environmental monitoring. So it also supports automated climate control. It also uses predictive maintenance and resource conservation across connected infrastructures. So it's a very useful sensor. So these are typically paired with temperature sensors and water sensors for remote monitoring of the environment. And next we have vibration sensors. So this type of vibration sensors are used to denote the vibrations. Recordings can be possible with their frequency, velocity, amplitude, and other variables. Okay, so vibration sensors measure dynamic variables. So, like as I told you, it measures frequency, velocity, amplitude, and to access the mechanical health of equipment, will be using sensors. So, by continuously monitoring these parameters, they can detect early signs of malfunctioning or misalignment or imbalance in machinery. We can use this type of sensors. So this enables timely alerts for maintenance. So when there is an alert, so the particular user may know there can be a maintenance issue, or by reducing the downtime and preventing cost failures, they can manage all these things. So from large scale infrastructure like water towers to factory equipment, vibration sensors are integral to use in predictive maintenance strategies, and it can be also used with operational reliability across industrial systems. So it's very helpful for monitoring from large systems like water towers, etc. Right? So it can also predict the malfunctioning or misaligned parts in a machinery. So this is the main use of vibration sensors. And moving on to the next part, we'll see the working and other principles in the second part of the unit 2. So with this, I'll conclude today. Thank you all.